can see how they change and speed up and slow down. So for that, visually, it makes it a little bit easier to understand. So first of all, make sure you use a line graph. We're going to be showing how the speed or the distance changes over time, and that is exactly what a line graph is for. Your time is always going to go on your x-axis, the bottom one, and your distance or speed goes on the y-axis. So time on the bottom, distance or speed on the side. And pay very, very close attention to the y-axis. Okay? We're going to look at two different types of graphs, and depending on what it says on the side, either distance or speed, you read the graph differently. So pay very close attention to the y-axis, that's the one on the side. So the angle of the line, so whether the line is flat or kind of flat or really steep, it tells us, it's called the slope. You hear that in math. The slope of the line is the angle of the line and tells us what's happening. So we're going to look at how the angle of the line changes and how it compares to other angles on the graph to see how the motion changes. So let's take a look at our first type, the time and distance graph. So time, as always, goes on the bottom, on the x-axis, and our distance goes on the y-axis. The slope tells us about the speed. So we can look at the angle of the line and know how the speed of the object is changing. If it has an up slope, which means the slope is going upwards, that means the object is moving forward. If it has a steep slope, a steep up slope, it means it's speeding up. So if we have a line that is going is up, but it's higher, like it has a sharper angle, that means it's speeding up. We have a flatter up slope, so again, a line that's going upwards, but not really high, just, you know, it's going up, but not a lot. That means it's slowing down, okay? So the angle of the line tells us if it's speeding up or slowing down. If it has a flat line, that means the object is stopped, it's not moving whatsoever. If it has a down slope, so the line is going downwards, that means it moved backwards, and we'll see that in a minute. If it has a constant slope, so the line from here to here is at this angle, and then from here to here is at the same angle, so the angle of the line hasn't changed, that means the speed stays the same. So it's moving forward, and the speed is the same. And these types of graphs can be used to calculate speed, and I'll show you how to do that here in just a second. So write all this down, and then we'll look at an example of the graph. Okay, so here is time and distance graph. So again, my time goes on the bottom because it's our independent variable, and the distance depends on what time it is. So it's the dependent variable, so it goes on the y-axis. And we're going to look at this and make sure it says distance here so we know how to read it. So this graph is about my cousin Katie, and she ran, or I shouldn't say ran, she completed a marathon. She probably walked most of it, in October. And so we're going to look at how her speed changed and how she moved during her marathon. So a marathon is about 40 kilometers. So remember, here it says my distance is in kilometers. So the total distance she's going to cover is 40 kilometers, and it took her 6 hours to do that. It was a long race. So at hour 1, we go up, and she covered about 5 kilometers in that first hour. So see how her line is going up here, but it's not real steep. I mean, she's moving forward, but not very fast. Okay. Between hours 1 and 2, look at that. Her line gets a lot steeper, because in hour 1 she only covered 5 kilometers, but in this second hour she covered 25 kilometers because she went from 5 to 30. So she covered a lot more ground, and so her line, the slope of her line got a lot steeper, and so it means that she's speeding up. So from hours 2 to 3, in this third hour, her line is flat. So what does that mean? If she, at hour 2, had covered 30 kilometers, and hour 3 covered 30 kilometers, nothing happened in this time. An hour went by, but she's not covering any new ground, so she stopped. And then maybe she twisted her ankle or had to wait in line for the bathroom or something, I'm not sure, but she stopped here. So for this hour, she didn't cover any new ground. So the flat line means that she stopped. Between hours 3 and means that your object went backwards. It's covering, at hour 4, she covered less ground than she had covered at hour 3. So from hours 4 to 5, at hour 4, she covered 20 kilometers. At hour 5, she covered 32 or so. So she's again moving forward. And from hours 5 to 6, she went from about 32, 33 kilometers all the way to 40. So she finished at hour 6. So with these 2 hours, we can tell that the speed is the same because the angle of this line doesn't change from hour 4 to hour 6. So in here, that speed is the same. So an upslope means you're moving forward, steeper, speeding up, flatter, slowing down. A flat line means you stopped, and a backwards line means you backed up. So remember I said that you could use this graph to calculate speed, and you just use the graph to get your numbers. So we know that speed is equal to distance over time. And what information does this graph give you? Distance and time. So you can calculate the speed based off of this graph. You don't even need the numbers. So let's figure her speed at hour 2. Okay? So at hour 2, she covered 30 kilometers. And 2 hours had gone by. So her time is 2 hours. So you have your distance and time, and then you just calculate your speed like normal. So 30 is the cowboy, he's on top, and the horse is on the bottom. He stays outside. 2 into 30 is 15. You circle your labels, write them top to bottom. So at hour 2, her average speed was 15 kilometers per hour. That's it. Like, you can find the speed just looking off the graph. Okay, so and that's our speed for the entire race up to hour 2. So for the first 2 hours, she averaged 15 kilometers per hour. But what if I just want to know her speed in between hours 1 and 2? I don't care about the first hour, because obviously she wasn't going that fast. She maybe got off to a rocky start. So I just want to know about this speed in here, between hours 1 and 2. So you can do that too. So you just look between hours 1 and 2, how much distance did she cover? Well, she started with 5, and then she went to 30. So how much distance did she cover in just this 1 hour? She covered 25 kilometers because she went from 5 kilometers to 30. So in just this hour, she covered 25. Because remember, we don't care about that first hour. And then how much time went by in this hour? Just 1, because you went from hour 1 to hour 2. So 1 hour. 25 goes inside. 1 stays outside. Your number is 25. So, between hour 1 and 2, she averaged 25 kilometers per hour, which is the speed of a slow-moving car. So, this is probably not very accurate. But, you can find out the speed of just this one segment. You don't have to find out the speed for the entire thing. So, this 15 kilometers per hour was from the start to hour 2, and then this 25 kilometers per hour was just hour 1 to 2. It was just that second hour. Okay? So you can do it either way. You can find the speed of just hours 3 to 4 or hours 3 to 5. You can do whatever chunk you want. You just find out the distance and the time, and that's it. So that's a distance and time graph. Time and distance graph. And they're pretty easy to read. The other type of graph is a time and speed graph. And as you can see, it's a little more complicated, but you get a lot more information out of this graph than the time and distance graph. So for time and speed graph, your time is on the x-axis again, as always, and your speed is on the y. Okay? So remember, you want to make sure you check that y-axis, because if you mistake this and you think that it's a time and distance graph, the angles and the slopes are going to be completely different things. So make sure you check that y-axis. The slope, or the angle of the line, tells us about acceleration. And acceleration is how fast it is speeding up or slowing down. Not how fast it's moving, but how much faster it's getting or how much slower it's getting. So if I'm driving in my car and I'm stopped and I start driving and I go from 0 to 15 miles per hour, and then I go from 15 to 30 miles per hour, I'm speeding up that entire time. I'm going from 0 to 30 miles per hour. I'm speeding up. Okay? And so that is acceleration. It also tells us about slowing down. So if I'm in my car and I'm going 30 miles per hour, and then I come to a stoplight, I have to slow down. And so I'm going from 30 miles down here it's moving slower, and up here it's moving faster. If it has a steeper upslope, that means the acceleration is increasing, okay? So if I go from 0 to 10 miles per hour, and then I go from 10 to 60 miles per hour, my acceleration is increasing because I'm speeding up a lot faster, okay? So that would have a steeper upslope. It means my acceleration is increasing. I'm speeding up, okay? A flatter upslope means I'm still speeding up, but not as much. I may be going from 0 to 10 miles per hour, and then 10 to 25 miles per hour. Okay, I'm speeding up, but I'm not going from 0 to 60. Okay, I'm going faster, but not as fast, if that makes sense. If we have a flat line, that means my speed is constant. So I've now hit my, 30 miles per hour. I'm going down the street, and my speed is not changing. So this does not mean stopped, like in the other graph. This means my speed stays the same. Okay. On a time speed graph, we can't tell if the object stopped or not. So we're just looking at the speed. If it has a down slope, it means it's slowing down. So regardless of how flat or steep the line is, if it's going down, it means it's slowing down. If it has a really steep down slope, it means it's slowing down more. Maybe I was going 60 and the stoplight's like right there. I gotta slow down really fast. So I'm slowing down a lot. If the flatter down slope, so it's going down again, but it's not steep like this one, it's just a little bit more flat, that means it's slowing down less. So maybe I'm only going from 20 to 0, right? Like I'm slowing down a lot less. And it has a constant slope, so the angle stays the same, right? Like the angle of the line stays the same. It means my acceleration or my slowing down is the same. I'm still speeding up, I'm just speeding up at the same pace. So I may be going from 0 to 10 and 10 to 20 and 20 to 30. I'm speeding up the same. Or I'm slowing down the same rate. So I'm going from 30 to 20, 20 to 10, and then 10 to 0. Okay, so I'm slowing down at the same rate. Okay, so let's look at a graph. This is all kind of confusing. Okay, so we are again going to look at Katie's marathon speed. We have time in hours. This should stay the same. The only thing that might change is the unit. You can have time in minutes or seconds or decades. It doesn't matter. Just make sure you read what that says. And then over here we have speed, which is different than our last graph. So this is a time speed graph, and it's in kilometers per hour. Okay, so this graph is going to tell us how Katie was speeding up or slowing down. So from the start to the first hour, she was going 5 kilometers per hour. She was not moving at all. This is 0 down here, 0. She went from 0 to 5 kilometers per hour. So she was speeding up because her line's going up. From 1 to 2 hours, she's now going 10 kilometers per hour. So she's speeding up even more. Okay, she went from 0, not moving, to 5 kilometers per hour, and now she's going 10 kilometers per hour. So she's speeding up. And then from hours 2 to 3, she's speeding up even more. Now she's at 15 kilometers per hour. She's really booking it. Okay, so from 0 to 1, 1 to 2, 2 to 3, she's speeding up this entire time. And if you look at the angle of that line is the same the entire way up. Because every hour, she is increasing her speed by 5 kilometers per hour. So see, she's speeding up the whole time, but it's at the same rate. And hopefully that makes sense. Okay, from 0 to 1, it was 5 kilometers per hour. From 1 to 2 hours, she increased her speed by another 5 kilometers per hour. And then from 2 to 3, she increased her speed by another 5 kilometers per hour. Okay, so she's speeding up, speeding up, speeding up, speeding up the entire way. From hours 3 to 4, she slows way down. So see, look how steep that angle is. Okay, if there was a flatter line, that would mean she was slowing down, just not as much. So from 3 to 4 hours, she was going 15 kilometers per hour, and now she's back down going 5 kilometers per hour. So she's slowed down a lot in this 1 hour. From hours 4 to 5, she sped up a little bit more. She's going 5 kilometers per hour, and now she's going maybe like 7. So here she's speeding up because the line's going up. But as you see, this line's a lot flatter than here. Because from hours 4 to 5, she only increased her speed by 2. She's going 5, now she's going 7. And over here, she increased her speed by 5. She's going 5, now she's going 10. So the angle of the line tells you how much she's speeding up. And here between hours 5 and 6, she's continuing to go about 7 kilometers per hour. So her speed is the same. So from hour 5 and hour 6, she's going the same speed. Okay? So speeding up, speeding up, speeding up, slowing here because